Today, we are diving into a fantastic logic puzzle. I mean, it's one of those that seems completely impossible when you first hear it. It's got a bar of gold, a week's worth of work, and it requires some seriously clever thinking. So, let's get right into it.
Okay, so here is the challenge. Imagine you've hired someone for a 7-day job. You have to pay them at the end of each day, but your only form of payment is a single, solid gold bar. The puzzle is, how do you pay them correctly every single day using only 2 cuts? Just 2. I mean, take a second and think about that. How do you get 7 payments out of 2 cuts? It just doesn't sound possible, right?
So let's really break down the scenario here, because the details are everything. We've got a 7-day job, one single gold rod that's worth 7 days' pay, and a rule that you have to settle up with the employee at the end of every single day. Let's get really specific with the conditions. So the job lasts 7 days. The pay comes from this one 7-unit gold rod. And here is the absolute crucial part. At the end of each day, the employee's net worth in gold has to equal the number of days they've worked. So after day 1, they have 1 unit of gold. After day 2, they have a total of 2 units. And so on all the way up to day 7.
Okay, so this brings us to the rules of the game. And, more importantly, it shows us why the answer that immediately pops into almost everyone's head is, well, just plain wrong.
Now, let's walk through what we all probably thought of first. The intuitive approach, right? You think, oh, this is easy. Step 1, I'll just make 6 cuts in the rod. Step 2, that gives me 7 perfect little 1-unit pieces. And step 3, I just hand 1 over each day. Problem solved. It's simple, it's clean, it's totally fair.
But, and this is the zinger that makes it such a great puzzle, you only get 2 cuts, not 6. So that simple, perfectly logical solution, it's completely out the window. And this is what takes it from a simple division problem to a real, head-scratching logic puzzle. I mean, how on earth do you pull off 7 payments with just 2 cuts?
So let's get to that aha moment. This is the 2-cut solution. And honestly, it is just a beautiful, beautiful piece of out-of-the-box thinking. So this is the million-dollar question, isn't it? If we can only make 2 cuts, where in the world do we actually make them on this gold bar?
Well, mechanically speaking, if you take any single rod and make 2 cuts, you are always going to get 3 pieces. That's just a physical fact we have to work with. So the secret can't be in the number of pieces, it has to be in the size of those 3 pieces. And here it is. This is the whole secret. The 2 cuts are made to create 3 very specific and very unequal pieces. You cut off a piece that's 1 unit long, a second piece that's 2 units long, and that leaves you with a third piece that's 4 units long. 1, 2, and 4. Go ahead and burn those numbers into your brain.
Okay. I know what you're thinking. Pieces of 1, 2, and 4, how does that possibly work for 7 daily payments? It sounds kind of random, right? Well, let's walk through the daily exchange step by step to see this elegant solution in action.
All right, let's follow the money. Day 1, you give the employee the 1-unit piece. Easy, they have 1 unit. Day 2, now it gets interesting. You give them the 2-unit piece, and they give you the 1-unit piece back as change. Their net total is now 2. Day 3, you just give them that 1-unit piece back. Now they have the 1 and the 2, for a total of 3. Day 4, you give them the big 4-unit piece, and they give you back the 1 and 2. Their total is now 4. See the pattern? You keep making these exchanges. On day 5, they'll have 5. Day 6, they'll have 6. And finally, on day 7, you give them the 1-unit piece one last time, and they're holding all 3 pieces, the 1, the 2, and the 4, for a grand total of 7. It works. It actually works perfectly.
So this isn't just some random numerical trick. There is a deep, powerful mathematical principle hiding in plain sight here, and that is the power of binary. You've definitely heard of the binary system. I mean, it is the fundamental language that all of our computers use to talk. Instead of counting in tens like we do, it's a system built entirely on the powers of 2. And with it, you can represent any number you can possibly imagine. And right here, this slide just makes it all click. Our 1-unit piece of gold, that's just 2 to the power of 0. The 2-unit piece, that's 2 to the power of 1. And the 4-unit piece, you guessed it, 2 to the power of 2. Our physical gold pieces were just a tangible representation of the first 3 digits of the binary number system.
And this is precisely why it works. With just these 3 pieces, our 1, our 2, and our 4, you can literally construct any whole number from 1 all the way up to 7. You need to make a payment of 5? Just combine the 4-unit piece and the 1-unit piece. Need to make 6?
use the 4 and the 2. It is a complete, perfect set that covers every single day of that week.
You know, this puzzle is so much more than just a fun brain teaser. It really teaches us a powerful new way to approach problems in general.
And it really all boils down to this one core idea. We didn't solve this by trying to make 7 identical payments. No, we solved it by finding the 3 essential building blocks, the 1, the 2, and the 4, that could be combined and recombined to make any payment we needed. We found the fundamental components.
And that kind of leaves us with a final thought to take away from all this binary way of thinking, this idea of breaking a huge, complicated problem down into its most basic, powerful parts. You can apply that to almost anything. So the question I'll leave you with is this. What's the biggest problem you're facing right now that you could solve by breaking it down into its smallest possible parts? Thanks for joining me.